Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover strength of materials in 6. The topic of this tutorial is a mixed bag of exam DP test questions. Round 5, question 4, the combined bending and twisting of shafts. The question is included in the video and the description box below. We have been asked to issue a cautionary note. When doing these questions, please use the method I'm going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks, even though your method and the answer might be right. See the cautionary note at the beginning of the video. Let's get straight into it. The question starts thus. A hollow shaft turns at 200 revolutions a minute. So, N is equal to 200 RPM. Now, and carries a flywheel with a weight of 5 kilonewtons. So, the weight of flywheel is equal to 5 times 10 to the 3. The flywheel is placed 300 millimeters from one bearing on the shaft with a length of 800 millimeters. Consider the shaft as simply supported. The allowable tensile stress and shear stress in the shaft must not exceed 85 megapascals and 65 megapascals. So, our stress is 85 times 10 to the 6, and tau is 65 times 10 to the 6. Respectively. The outside diameter of the shaft is 80 millimeters, so big D is 0,08 meters, and little d is 0,07 meters. That is the inside of there. Now, we've only got one question to answer, but it has many parts. Calculate the power that can be transmitted by the shaft if the maximum torque is 13% more than the mean torque. So, T equals 13% more of T mean. Now I'm going to draw you a simple picture of what this should look like. Here's your hollow shaft. It's simply supported here and here. The whole shaft from there to there is 800 millimeters. Now from here, I would say, now here's your flywheel. Here's your flywheel, and that is 300 millimeters from your bearing. Alright, now LT, that's L total of this, is 0,8 meters, and L to flywheel is 0,3 meters. Okay, so now we've got all our information that has been given to us. So now what we'll need is to calculate M, NE. We'll need to calculate torque, proper torque, and torque and the equivalent torque. That is what we'll need to calculate to get everything that we need. Because what we need to do, we're working towards this formula here. We're working towards P equals 2 pi nt over 60. Now, what we have for this formula is we have N, we don't have T. we need to work out what t is. So, in order to do that, we need t. So, m equals w a b over L equals, now this will be our weight, which is 5 times 10 to the 3 times 0,3 times 0,5 over 0,8. 0,5 is what's left over because you're doing the full length of your shaft. Right. So our answer for M is 937,5 Newton meters. So M 937,5 Newton meters.
While you're standing back there, remind them to draw a picture, helps them visualize what's going on, and to write the values to the right and working out to the left, and then as the values come out, you just keep on writing them down, either now or later on in the video.
At the end of it.
Yeah.
Okay, now that we've got this, we'll need to calculate ME. ME's formula is ME equals pi times d to the power 4 minus d to the power 4 stress over 32d. That is your formula. Now we have every value that we need right here. So this will be pi times 0,08 to the power 4 minus 0,07 to the power 4 times 85 times 10 to the 6 all over 32 times 0,08. So ME is equal to 1768,06 Newton meters. Okay, so we got 1768,06 Newton meters. Alright, now we will need ME again, because we're going to work out the maximum torque. We're going to work out the maximum torque. We will use this formula. ME equals a half times M plus the root of M squared plus T squared. Okay, now we have values for each of these except T. We want torque. So what we're going to do is, now we've got ME, which is 1768,06 equals a half times 937,5 plus the root of 937,5 squared plus T squared. Alright, so now what we're going to do is we're going to multiply by 2, because when this comes over and it's a multiplication, it flips to stay a multiplication. So 1768,06 times 2 equals 937,5 937,5 plus the root 937,5 squared plus t squared. This got me to 2598,62. Okay, what I've done here, let me just get this quickly. The actual answer is 3536,12 minus 937,5 equals the root 937,5 plus t squared plus t squared. Okay, now that we have that, now we can minus 2598,62 equals the root of 937,5 squared plus t squared. Now what we have to do is square both sides. So this side is squared and that answer is squared. Now we've squared both sides, so we have 2598,62 squared equals 3937,5 squared plus t squared. Okay, now what we do next, we take 2598,62 squared minus 937,5 squared equals t squared. Now we root that and root this. Then we have t all by itself. And we have t equals 2423,67. So t 2423,67. Okay, that is a lot of working. Now we don't have our t mean. We need t mean to calculate up top here. We need t mean. My mistake, we need t mean. So all we have to do now is say t is 13% more than t mean. So all we have to do is take this, divide it by 1.13, and then we get our answer. So what we're going to do now is take our answer. Okay, so we want t mean, which is equal to t over the percent. So what we need is t mean. So we have 2423,67 divided by 1,13. 2423,67 divided by 1,13. And that gives us t mean gives us 2144,84. So now what we're going to do is t mean is 2144,84 Newton meters. Newton meters. Alright, so now we can use this formula up top here. So what we have is power is equal to 2 pi times 200, because that's N, which is 200 revs a minute, times 2144,84 all over 60. So power is equal to 44921,424 watts. So what this will be is, if we want to convert it to kilowatts, we would say it is 44,921 kilowatts. That is how much power this whole thing is transmitting, with this flywheel and everything on it. Okay, on a side note, please, when you're doing shafts and anything like that, always try and draw a picture, because it helps you visualize what you're actually doing. So it helps you visualize it and see it and everything. And also, whenever you get a value, always put it on the right hand side of your page, because that is neat, and then you're not scratching around for values. You will never scratch around for another value if you do it this way, as I've shown you. So doing it like this, each step coming through, with each one done, then it shows that you've done each step, so that helps you when you deal with the next sum and the next sum and so on and so forth, because they catch up with you. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.